All right, welcome everyone. If this is your first Sentry monthly live workshop, we're happy to have you. For those of you that have been to one before, welcome back. Today's topic, if not already made obvious, is going to be about tracing for the front end to the back end. We'll get started with just a quick agenda, do some introductions, take care of some housekeeping stuff, and then get you over to Dustin, who's going to walk you through our workshop today. So first and foremost, we'll jump into what tracing is, look at a light history lesson, talk about the difference between profilers versus tracing, go through some definitions, what's a trace, what's a span. Then we'll talk about why tracing, what does it help a developer answer? Look at getting full coverage and full context over problems or things that you're trying to solve. And then lastly, we'll jump into a demo to look through some common scenarios and some use cases before wrapping it up, as we always do with Q&A. We will have a little bit of time after section 3 here to get some questions answered in the middle of the workshop. So if something comes along during the what is tracing or why tracing, feel free to ask those and we'll address them before we jump into the demo. Today's host is Dustin Bailey. Dustin's a solutions engineer here at Sentry, and he is joined by Jeremy Bork, a product manager here at Sentry. Jeremy will be in the Q&A if you have questions, answering those throughout the workshop. Just some housekeeping, as I said, this question comes up all the time. This will absolutely be recorded, and we'll get the recording out to you all next week so that you can share it internally or rewatch some sections you found interesting. As I said and mentioned, make sure to use the Q&A feature to ask your questions. If you see something that's already been asked, upvote it, and we'll do our best to get to it in the middle or the end today. And then lastly, at the end of the workshop, 2-question survey is going to pop up. We do these workshops for you 100%. So we want you to have input on how we can make them better, format, content, anything you can think of. So please, if you have time, take a minute to answer those 2 questions so that we can continue to make these better in the future. I think that's all from me. So with that being said, I'll just pass it over to Dustin to get the show started.
Thank you, Schaefer. Let me just share this. Okay, awesome. Quick confirmation that folks can see my screen. Schaefer, probably just from you. Awesome. All right, let's get started. So in today's discussion on distributed tracing, we're going to be focusing in on one of Sentry's 5 major product pillars. So that's going to be performance monitoring. And again, we're going to be focusing on Sentry's method for recording connected operations across multiple services. Now, historically, this data had been circumscribed to DevOps engineers, to infrastructure engineers, but presently engineers of all types can benefit from using Sentry's performance monitoring product. So in this case, whether you're a full stack engineer working on a single page application, perhaps connected to an API server on the back end, or you're an engineer managing dozens of connected microservices, now both errors and related performance data are captured for you together as we follow a request from service to service. So you're able to identify any bottlenecks or issues that might be impacting your entire system. Let me click on the screen. So as a part of that, you're also going to get visibility into industry metrics such as AppDex score, throughput, error rates for all transactions between services in which you have Sentry's performance product instrumented. You're also going to get contextual detail here in the form of tags, which you may or may not be accustomed to. Being a Sentry user, you can start to see that we have related issues being serviced here with performance data. All of this forms a nice constellation of both error and performance data within the Sentry product. I think now is a good time to highlight or emphasize that Sentry's performance product is focused on mostly focused on what happened and when. So the interconnectedness of your systems or your systems and services, as opposed to providing you more isolated statistical samples, perhaps related to how much memory a particular process is consuming, or how many instructions were executed as a function of a particular process, as you might see in a more traditional profiler. Okay, great. So I think it's going to be valuable for this discussion to start to build a foundation of understanding related to how we think about distributed tracing at Sentry. And that discussion is going to start with this diagram here, and it's really going to have three major components. So the first component is going to be the trace. This is the operation that you as a developer are interested in instrumenting observability around. So this can range from a number of things. It can be anything from a page load being kicked off from your web app, which is particularly relevant to this diagram, to a flow that your user is experiencing within your application. So for instance, a checkout flow. As we move to the second major area of discussion within this diagram, we reach the transaction. So traces are composed of transactions. You can generally think of transactions as calls to services in which you have Sentry's performance product instrumented. So in this diagram, our first transaction is going to be the page load kicked off by our web application. If we stick with this transaction and move to the most granular level of this diagram, we come to spans. So spans in this case are going to be the atomic units of work that our browser is completing to load the page. You can think of spans as representing resources being loaded. You can think of spans as representing UI component lifecycle events, depending on your SDK or the front-end framework you're using in this case. You can also think of spans as capturing requests made to external services. So in this case, we can see that as part of our page load, we're making a request to a backend service for some JSON. These requests to external services mark the start of a new transaction within our trace. So now we have a transaction representing the incoming request to the backend. This backend is going to have its own atomic units of work. You can see that one of these is making a second request to an external service in which we have Sentry instrumented, thus starting another transaction within our trace. This transaction is going to have its own atomic units of work. Once this work is completed, all of these spans, and you can think of spans, or rather transactions as trees of spans, are going to be packaged up, sent over to Sentry with not only sort of span level detail, but other contextual information, tags, and represented for you within Sentry's performance dashboard. So you can trace not only within spans, within transactions, but also spans across transactions across the entire trace that you've captured. That's really the general discussion of how we conceptualize distributed tracing here at Sentry. And I think as we move our conversation today from more abstract in this diagram to concrete, we really want to focus on two primary areas right after this and throughout the presentation. So the first concrete area is going to be how can your team derive value from the performance product? And then we're also going to talk about the instrumentation, the code, the data that underlies the value that you are going to derive from instrumenting Sentry's performance. But let's start with the first part of that, talking about use cases. So tons of teams have adopted Sentry's performance product, and they've adopted them in various ways, all contributing value to the team. So we've seen teams adopt Sentry solely on the front end and use it as a tool for communication with backend teams. So in this case, front end might be utilizing some APIs. They might have realized some latencies associated with those APIs, and then use the span level detail as a communication point to backend teams that are responsible for those APIs. We've also noticed front end and backend teams adopting performance to monitor SLOs, to improve upon SLOs, in this case, specifically related to transaction times and payment networks. We've also seen mobile teams adopt the performance product to debug hard to replicate issues in critical login pathways. We're constantly using performance within Sentry ourselves, looking for high failure rates, odd status codes, N+1 and database queries, investigating slow page loads. I think the main takeaway here is that there are myriad ways that your team can immediately benefit from adopting the performance product. And these only are starting to scratch the surface of the many use cases that we've observed among our customer base. So now I think we're going to start switching into a more detailed conversation. So let's continue this concrete talk and move into instrumentation and data that sort of underlies the value that that was captured in all of these use cases. And I think a good starting point for that is going to be our documentation around performance. So just a quick orientation here. The demo we have planned today is going to be a JavaScript front end that's using React and a Python backend. So that's where we are in our documentation here. Of course, we have robust documentation for any platform you're interested in using performance on, but we're going to focus our conversation here for the most part today. And specifically, we're going to be focusing on the Sentry init statement. So the Sentry team has worked really hard to minimize what's required for instrumenting performance while also maximizing the benefits you get automatically out of the box. And that's where we're kind of going to focus our conversation. First and foremost with performance is automatic instrumentation. So in this case, there's a couple really important pieces I want to highlight. The first is going to be the tracing integrations package. That's kind of essential for instrumenting performance. And now we can start to move into the init statement. If you use Sentry, this is really where everything begins. Of course, you need a DSN key. Sentry needs to know where to send your events within Sentry, which projects rather. And now you're going to start using or instrumenting the actual browser tracing integration in this case, because we're instrumenting this on a front end service. This is where our instrumentation begins. So in using the browser tracing integration, Sentry is going to automatically out of the box give us transactions for all page load and navigation events. So in this case, if you recall the diagram we were looking at, these are where the transaction within a particular trace is going to begin. So either with a page load or a navigation event. Now, if as part of that page load or navigation, we have any external requests for resources, fetching any type of data, Sentry is also going to automatically add those requests to the ongoing or the currently running transaction, so long as you're specifying the destinations of those requests within this tracing origins array. So now Sentry is going to start building that detailed transaction for you automatically, whether that's a page load that also has external requests or a navigation event. One thing that I'll touch on very briefly here, it seems like this example has some custom instrumentation around React Router, which we provide support for various versions of, and this is what's going to give us parameterized transaction names for navigation events that are utilizing React Router. I won't get into the details of this. We have great documentation on it, but just so we can, sort of fully explore what's going on within this initialization statement, and we can start to scratch the surface of other integrations we provide. The final and most important piece, another important piece of instrumenting performance is the trace sample rate. So this is what's going to tell Sentry, or you're going to use this to tell Sentry the proportion of transactions that you'd like to sample. So this is set at 1 right now. That reflects we want 100% of our transaction data sampled. Now, this can be valuable when you're first instrumenting performance to make sure that you are actually getting all the data that you expect to see. But this can also be tuned later or during the instrumentation process to give you, or to a rate that represents a more representative sample depending on the characteristics of your system. But that's all that's required for automatic instrumentation. We do provide additional ways to get more specific. So you can sample transactions based on transaction context and metadata, and that's the traces sampler. We won't get into that, but again, we have plenty of great documentation on how you can sort of get very specific with which transactions you're interested in. And you can actually specify the proportions of each type of transaction you'd like Sentry to sample as well. So we're going to shift from auto instrumentation to custom instrumentation. We do provide ways outside of all the benefits you get immediately from a few lines of code to further instrument performance within your service. The best way of understanding this is sometimes just looking at the code and going through an example here, and that's what we're going to do quickly. So our shop checkout here, we're instrumenting a particular function call within Sentry, which is fine. And to do that, it starts with starting a transaction via the SDK. So these transactions are going to be, we're going to give this transaction a name. So Sentry will, the distinction here being in auto instrumentation, Sentry is going to use various metadata available from APIs to name transactions. In this case, we're going to name this ourselves. So we're starting the transaction here and we're adding it to the current scope within Sentry. So now we're going to perform, we're going to have a function call here that performs some validation of the shopping cart. And I want to highlight that this represents an external call. Now, if you recall, in that auto instrumentation section that we just went through, because we have that set up and configured, this work or this call is going to automatically be added to the currently running transaction for us. Nothing else is needed for us to get this information into our span level detail. However, if you do want to instrument custom spans for function calls within this shop checkout function, you can do so as well. And this is what it looks like via the API to do that. So we're starting a child span here as part of this transaction. We're going to add some metadata to it, so an operation, and you'll see why these operations can be valuable at a future point when we start explaining some data here. And then we're going to actually perform a function call. So we're going to process and validate the shopping cart. This will be added, or the characteristics and metadata associated will be added to the current transaction as well in the form of a span. We'll finish that span after the work is complete. We'll finish the transaction. This will all be packaged up for us, sent off to Sentry, where we can explore this and its full context associated. And we'll actually get a good example of what this looks like because we'll be simulating this in one of our traces very shortly. So I know that we covered a lot there. Schaefer, I feel like I should kick it back over to you to see if there's any immediate questions that we can address about tracing in the meantime.
Yeah, we've got a few that have come through. The first one is, what is a typical trace sample rate? Is there like a number between that 0 and 1 that you think is a good benchmark or place to start after maybe you start with 1 and move down, or start low and move up to 1?
Yeah, so I think this is a little more difficult of a question to give a specific answer to because it's going to depend a lot on where you're instrumenting performance. So again, you can see benefits from 1 in the case where you're confirming that you're seeing all of the data you want to. But depending on perhaps the throughput of your system, you might be able to get a more representative sample at a lower rate, or you might need to oversample depending on your volume as well. So I think that's the best guidepost I can set now is depending on the throughput, the transactions that are actually being collected, you can adjust that sample rates. So if I mean, thousands versus orders of magnitude greater than transactions, you might be able to get away with a smaller sampling rate than you would if your system isn't necessarily, I guess, high throughput or very high throughput. So it's very relative to your system, that answer.
Got it. Okay. Thank you. More of a general question. How do you add performance monitoring or tracing to serverless framework applications running on AWS API Gateway?
So I know that I may have to check the docs, but I do know that we provide some support for performance in serverless. So I think the answer to that question might be best served by going into our documentation, specifically our serverless docs, and evaluating support for performance there for that particular use case.
Cool. Does automatic instrumentation work out of the box for a single page application?
So out of the box, I think really what you saw us go through. So for a single page application, out of the box meaning, well, what we went through when it comes to configuring the integration. So this is going to be required for getting things out of the box. So automatically instrumenting navigation, automatically instrumenting page loads, automatically instrumenting any fetch requests as part of those. I think that was covered, but this is kind of the bare minimum required to get the best and the most out of the box for the performance product in that context. Yeah.
Maybe I can add on to that, Dustin, as
Sure.
well. Look, I think, as you say, broadly speaking, the answer is yes, in the sense of like once you turn it on, you will start to get instrumentation. A lot will depend on the specific libraries, frameworks, and routers that you're using. So if you're using, for example, React Router, you'll get a fairly rich experience out of the box with a lot of span details. Your page load transactions and your navigation transactions will be separated and identified, and it'll work for a single page application like that. For some other frameworks, you may get less span detail, or you may have different operations that aren't covered out of the box. So for certain frameworks or certain setups, you may need more customization. For others, it'll be more automatic, and there's kind of a spectrum there. But you will get something out of the box. Like you will get transactions, and you will start to get tracing out of the box. And then it's up to you in terms of like, do you want to kind of go deeper and customize that to get additional detail in certain places.
Awesome.
Thanks, Jeremy.
If we set the trace, and I'll just ask 3 more questions and then we'll continue on into the demo. If we set the trace sample rate to 1.0, will this cause any overhead?
So we definitely don't encourage you to, set the trace sample rate in a production environment to 1.0 and sort of let it rip from that perspective. We're definitely, it's definitely going to vary based on your particular service. So throughput being considered again. For higher throughput environments, we definitely don't recommend starting at 1%. We're definitely doing some work, and the conversations are happening internally when it comes to profiling overhead related to that. But this is definitely specific to, the answer to this is specific to the service and the SDK as well. And if anyone has specific questions, I'm happy to follow up with you after this webinar. But I'll kick it over maybe to Jeremy if he has anything to add to this. Otherwise, I think that's probably the best answer I can give currently for that.
That's pretty accurate. I think that's very accurate. I guess I would just also sort of give the general disclaimer that any kind of instrumentation or monitoring that you add is going to add some amount of overhead, and the particular characteristics of that are going to vary a lot from system to system. If you're doing, for example, if you're doing front-end monitoring, a lot of the work is happening in the browser on the client side. So that distributes better, and you can sometimes tolerate higher sample rates there for that reason. On the back end, if you've got, if you've instrumented a backend application, then most of the work is happening in one place where all your backend APIs are coming. That may have, a significant performance impact or a significant additional load placed on that server, depending on how much scaling overhead you have and how busy the server is already and your transaction volume and a whole bunch of things. I would agree. We definitely don't recommend setting it to 1.0 in production in most circumstances. That would be a very exceptional case. But the best thing to do is measure, because everybody's the performance tax, if you will, that any tool will introduce is going to vary a lot depending on sort of your local setup. And the best thing to do is try to measure that and get a sense of it. And I would say for safety's sake, particularly if you're going to do this in production, start small and work up, as opposed to starting big and working down. And then you'll get a sense of, that's a safer approach.
Cool. 2 more quick ones and then we'll continue onward. What happens to traces that are incomplete, as in server crash before the transaction could finish?
So I think there might be 2 parts to this answer, and Jeremy might be able to color it a little better, but I know that Sentry uses head-based sampling. So this might not cover where the network crashes in the middle of a transaction, but this does ensure that when a transaction is sampled sort of at the start, it's guaranteed to continue to be sampled as it continues through, well, guaranteed to an extent, I guess, in this particular question, to be sampled as we trace that request from service to service. I believe that if there is a network interruption during the transaction, you might see, that might be where your visibility stops within Sentry. So if that transaction is collected, say on the front end, you might not be able to trace it to the back end, but I think that's where Jeremy might be able to add some more color to any network events that are occurring during the transaction flow.
Yeah, happy to jump in there. Yeah, there's a few different scenarios that can arise here, and a lot depends on sort of the nature of the crash and when it crashes. From Sentry's perspective, what you'll see in the app, like essentially there are transactions that made it back and there are transactions that didn't. If the transaction didn't make it for whatever reason, it never arrived or wasn't received intact by Sentry, you won't see it in the app. It's also the case that the distributed tracing relies on passing headers from one call to the next. So if you crashed before a transaction could be sent, and before, say, the trace header was passed to a backend service, or it was crashed, if the nature of the failure interfered with that being sent, then you will sometimes, that might be the end of your trace because the trace header didn't propagate. On the other hand, if the trace kind of was collected up, if the trace propagated properly and the transactions were created properly with the tracing headers intact, but some of them didn't make it back to Sentry, you will see whatever we received. And if you go into the trace view page in the product, you can see kind of the whole sequence of events. Sometimes you'll see extra transactions that are sort of dashed line connected to the top because we don't have the full structure. And what that means is something in the middle didn't make it back or wasn't instrumented in the first place. And so we have kind of an incomplete trace, but we will show you everything that we saw regardless.
Awesome. Thank you both. The last one, and we'll continue onward. If a single account has multiple projects, say front end, back end, APIs, does a single DSN work, or will you need a separate DSN for each project?
So we usually, I think it's one of the better practices within Sentry to have one project per service. So in that case, you would have a separate DSN per project. I think that's something that we highly encourage, and is probably the general recommendation. Within the performance context, that would also probably be the recommendation. Having one project say, well, there are different ways, and we've seen various types of project setups within Sentry, but I think the general recommendation is one project, one DSN key, and performance instrumented in each of those projects. Yeah.
Great. Cool. Well, we will continue onward. There's some more questions we'll get to at the end, but Dustin, I'll pass it back over to you.
Great. So now's when we're actually going to jump into a sample application here and simulate some traces. So we're going to be interested primarily in two types of traces. One is going to be for page load, and we're going to investigate what should be a slow page load here. So let's reload our application of our tool store. You can see there was some latency in the page load. You can see that a payload was sent to Sentry with the transaction information for that page load. And the other trace of interest is going to be a checkout. So we're going to add some of these very expensive tools to our cart here, and we're going to attempt to check out. And what you're seeing now is some latency associated with the checkout, but also an error occurred, and a nice widget that Sentry provides for collecting user feedback that could also be associated with this issue. Some more payloads were sent to Sentry. We're going to investigate the contents of those payloads, but for now, keep in mind two traces, one page load, one slow page load that we're going to investigate, and also a checkout flow that we've manually instrumented that's going to be very similar to the documentation that we already walked through. But let's jump into the performance dashboard finally. Great, so now we're within our performance dashboard. There's a number of helpful visualizations here and other items that come out of the box with Sentry's performance. And I think at the forefront are our web vitals, and I'd be remiss if I didn't touch on these as part of the performance conversation, briefly at least. So these are the web vitals that are formed and recommended beginning to be standardized by Google. So largest contentful paint, first contentful paint, first input delay, in addition to others that are provided with some transaction or as a part of transactions. But first and foremost, you can jump into any of these web vitals and track the P75 over time for that particular web vital. P75 being the general benchmark that Google recommends. Well, they recommend benchmark or sort of various P75 levels, but we're tracking the P75 as the best representative sample of our large contentful paint data in this case. You can zoom in on peaks and valleys through our interactive time series here, and all the transactions that comprise this data will update accordingly. So you can sort of get to the bottom of any increases in, say, P75 values that you're noticing for whatever time period that you're looking through. But we're going to sort of stay focused on transactions and continue to go through some of these visualizations, and I'm going to touch on a couple more helpful ones that we provide here. So right now we're focused on front-end transactions, specifically page load operations here, and we're aggregating data across all of our page load operations currently for the last 7 days. And we have a couple of helpful visualizations for this too. So we have a histogram here where you can get a general sense of the central tendency for our LCP. You can also see LCP over time, looking at zooming in on any sort of slice here of any peaks or any dips in LCP. We also offer some other helpful visualizations here, such as throughput. But LCP is really the measurement that we're focused on for assessing the overall end user experience for our that's represented as a part of our page load transactions. You'll always get a sense of the raw number of events for the particular time horizon that you've selected here. So we know that we're looking at around 38K events for the last 7 days, 38K transactions. And as we continue to scroll down, you'll start to see probably one of the, what we're interested in most for this discussion today on distributed tracing, and that being our transaction categories. So in this case, we have one transaction category for our page load here. So this is the page load we just simulated that loaded all of our tools. This naming convention, again, this has been auto-instrumented for us. So the name is taken from the window.location. Depending on, we talked about React Router a little bit. This is where you'd see parameterized transaction names as well, if you're using that integration. We have a couple helpful overview statistics for web vitals pertaining to these front-end transaction categories. So you can see generally LCP, FID, FCP, the unique users associated with this transaction category, in addition to user misery. And user misery is kind of a good way to get a quick indication of the proportion of your users that are experiencing transaction times 4 times greater than a threshold you specified. So in this case, we've specified 300 milliseconds as the acceptable threshold for this particular transaction, for this particular page load category transaction. And you can see that a majority of our users are experiencing latencies greater than 1200 milliseconds here. So not so great. Perhaps we want to investigate this category and jump into the actual detail. Okay, awesome. So quick orientation, we're within the tool store transaction category. We're looking at all of the data aggregated across all of our page loads that have been auto-instrumented for us. And now we can start to use some of Sentry's really helpful tools to start building profiles for transaction types or transactions we're interested in within this particular category. And the first way you can do that is this really helpful filter dropdown. So we have different types. You may have not noticed that we do have operations that you can specify when you're manually instrumenting, but we also have operations that are auto-instrumented for you. And you can use these to sort of start building up a profile or building up transaction characteristics that you're interested in, or filtering based on them, I guess is really the better way to put it. So for instance, if you're interested in all of our slow HTTP operations across these page load transactions, you can sort of filter by that operation, that particular operation type. Now we're looking at slow HTTP operations, so the 95th percentile here. If you wanted to look at outliers, you can now do that as well. You can use any of these filters. So if you're interested in outliers for resources being loaded, outliers for database queries, which perhaps we'll look at in a few minutes, you can use these helpful filters right off the bat to sort of explore this particular sample of your data. Before we jump into some of these actual outliers for page load, I want to highlight that you also still have web vitals represented for you for this particular transaction category. You have status breakdowns related to this transaction category as well. So if you're interested in exceptions or transactions within the page load that have exceptions associated with them, in this case, you can add internal errors to your filters, and then you'll be sort of looking at that subset of the data. But for now, let's jump into one of these page load transactions and see what we get at the span level. Okay, awesome. So first and foremost, we're still within our front-end project. We get a nice breakdown next to our waterfall here of operations contributing most to the latency observed here. Now, because we're already sort of filtering on HTTP, we might have had that assumption going into this data, but this is a good way, in the case that you're not filtering, to get an early indication in your decision-making and your triaging process as to what operations might be contributing to some deficiencies here. So if you were to recall that diagram, user memory, to the best of our abilities here, we're remembering that traces can be, or transactions rather, can be thought of as trees of spans, and we have our initial span here representing the page load. And then we have all of these spans that were auto-instrumented for us via the SDK. So browsers fetching resources. We have React component lifecycle events here. And as we continue to scroll down, we can start to see we have a culprit here that might have been contributing to that latency we observed in our page load. We could have gotten here quicker via the operation breakdown, but now we're here anyways, just sort of as an exercise going through the span level detail. We can open this span up, And this is where we can get some more helpful information. So mostly related to, you can look at durations here, methods, URLs associated with this particular operation. But what's most interesting for this conversation is the child transaction here. So Sentry is going to give us a nice preview here, or a nice indication that we have another transaction that's being kicked off as a part of this request from our front-end service. If we wanted to jump directly into this transaction, we can do so simply by clicking this button. But I wanted to point out that you also have the trace navigator here at the outset. So if you're interested in getting directly to the child, or just interested in another pathway to get to the child transaction, you can click on this button as well, and we'll be taken directly into our backend now. So let's orient ourselves again. We have the project here. We can see the trace navigator. There's nothing further, no child events here. We can see the status associated with this backend transaction. We get nice contextual tag details with the transactions in Sentry, or sorry, as a part of the transaction within Sentry. And we can start to sort of repeat that process of looking at the operation details. It appears that we have some manual instrumentation here related to DB function calls. We can go into the span level detail, see that we have a span being created for the incoming request to our backend. We can see that we have another span for this get all tools functionality in our database that has 3 sort of child spans associated with it. Some auto instrumentation here, it looks like, for some popular database ORMs. And we also, as a part of that, are getting some instrumentation around the exact query that was run here that appears, at least for the purposes within this span, to have taken a very long time. So in effect, we've traced the latency we observed on the front end into the span level detail on the front end, into the span level detail on the back end. We've used a bunch of helpful filters and tools along the way. We're within an outlier right now, and we've effectively identified this as resulting from an inefficient database query. In this case, this is more of an artificial latency that's been added to this query, but this could represent an N+1 database query or some other large table join. The root causes, of course, aren't necessarily important for this conversation. It's important to know that we utilize Sentry to trace this from the front end to the back end, and used all the contextual information in our triaging process as well. I think this is maybe another good point to pause. However, I wanted to show one more, perhaps, or the second trace that we wanted to illustrate that we manually instrumented, being our checkout flow. So I guess before we pause, let me jump into that trace really quickly. And then, let's get into admin JavaScript here. Off of that. Let's jump into our other front-end transactions. And now you're going to see the checkout that we named ourselves. So that's not the same name that you saw in the documentation, but now this is a manually instrumented transaction within Sentry. We'll get similar, these aren't web vitals necessarily, but these are the relevant latency percentiles associated with this checkout transaction. Starting on our front end, users, user misery, all the same sort of helpful overviews we've gone through. We can dive into the detail of this as well. Okay, so a lot of the same orientation here. One thing I didn't mention in our other trace was how you can use the query bar. So if you're interested in paring this data down to a specific browser type, so if we're interested in Chrome-based browsers, we can do so. If we're also interested in looking at perhaps the outliers for loading resources when it comes to this, or the outliers for, well, we did HTTP last time, and that's probably the most relevant for this conversation. But now we can start to look at slow HTTP operations for this manually instrumented checkout transaction category. If we were to jump into one of these outlier cases, actually, I kind of want to jump into another one just to illustrate. Let's jump into recent transactions. Okay, so you're going to notice something immediately different here, something that we referenced at the beginning of this presentation. Both errors and performance or related performance data are now being captured together within Sentry. So that's what Sentry is indicating to us in various ways on the screen right now for this particular transaction. You can see in the trace navigator, Sentry is telling us that an exception was captured on the front end at the start of this transaction. We have a child transaction as well, and we also have an indication that an exception occurred within that child transaction too. So there's a lot to look at right now when it comes to triaging the issues we experience with checkout. So let's start on the front end right now in our front end transaction and see what we can deduce to see if we can get to a root cause in this service. So if you click on the root span here or the initial span here, you can see some previews of the error detail associated with this particular transaction. You have the option to jump directly into this exception or this event detail. And if we do so, now we're sort of going to orient ourselves again. So we're within the exception detail that occurred during the transaction. And we provide helpful ways to jump back into the actual transaction in case you need to sort of switch back and forth as you're triaging this issue. But you get all that helpful contextual information to accelerate your decision-making and your triaging process here that you're used to with Sentry errors, but now within the context, larger context of transactions and debugging across services. So suspect commits, ownership, suggested assignees, tags here, unminified stack trace. So all this is available to us. Of course, if we look at this stack trace, this error message is rather ambiguous. This could be something we could work better on in the front end, but it appears that we need to dive deeper to get to the root cause of this. We know that an issue exists in the back, or at least in a child transaction. So why don't we jump via this helpful tool within the actual issue into the transaction on our backend. Okay, so all the same detail we saw on the front end, we have an exception here. Sentry has many helpful indications of that. We can either jump into the span level detail, the operation breakdown, seems like process order. We have some manual instrumentation around a function here, process order, that's contributing to a lot of the latency observed. We don't know if this issue is related. There might be two things going on here. There might be one, but we can then start to triage the actual exception or look into the actual exception in the same way we did so on the front end. Follow this into the exception detail, utilize all that's available to us, including the stack trace. In this case, it appears we have something on the back end related to not having enough inventory for the request we made starting on the front end. Perhaps this could be handled better on the back end. Perhaps this could be handled better on the front end. You'll also notice the name of, you have the file name and the actual function that was called. Notice that it's process order, so it seems like what we noticed in the transaction level detail is related. We can jump back into the actual backend transaction, but we've effectively reached a conclusion or a root cause at this point that we had an issue during this manually instrumented checkout transaction that's related to this function that has some latency associated with it. So you can see how something ambiguous on the front end, we're able to either communicate with our backend team or handle this ourselves in a full stack context by tracing it across services into the backend and utilizing Sentry's exception detail. Okay, that was a lot. And I think this is a great point to pause. Those are the two major trace categories that we're interested in here in showing at Sentry, or for the purposes of the distributed tracing demo discussion today. I'm going to kick it back over to Schaefer and see what we have going on for questions related.
Thanks, Dustin. Yeah, we've got a lot of them. I'll just kick right into it. The first one, someone was asking if they can see the mean histogram and standard deviation stats for the HTTP duration.
So I don't know if we can do that currently, and maybe Jeremy can speak to if that's something on our roadmap or something that we're having conversations actively about.
Sorry, I had a little hiccup there. I didn't catch the question. Can you repeat?
Yeah, sure. Can we see the mean histogram and standard deviation stats for the HTTP duration?
I think the mean may be possible to see, although I'm not 100% sure. You can sort of visually see those things on the histogram, but I don't think you can, I don't think we actually report out on the actual value of what is the standard deviation. You can certainly get a sense of it by looking at the histogram. And the filter bar will let you filter to whatever time range you're kind of interested in. But those are things we could add potentially to Discover. So that's an interesting feature request. Thank you.
Great. This use case that you showed is web-oriented, is the same, isn't the same for mobile apps, say made with Flutter.
Yeah, so performance is definitely, depending on the SDK, you're going to get different and varying types of auto instrumentation and performance related data. So I know that we have been working on, for instance, in Android and iOS, rolling out various performance features related to activity loads, related to HTTP interceptors, particularly for Android. I might need to reference what's available in our docs currently. I know that I'm not sure how supported performance is currently for Flutter, but it is going to vary. So we're definitely working on measurements that are helpful within the mobile context. So related to warm start times, cold start times. These are things that are starting to be internally worked on at Sentry. But I'd say the best resource is probably our documentation, to the extent to which the SDKs for mobile currently support the performance experience. Yeah.
Cool. If you only have the performance products enabled on the front end, does this just exclude those backend related spans and transactions?
Yeah, so as we mentioned, we do see teams using performance solely on the front end and deriving benefit from it, but your visibility will stop. Say we were investigating those HTTP or those latencies related to external calls as part of our page load. That is where your visibility would stop if you don't have it instrumented on the corresponding backend service. However, that's not where the triaging stops, as we've seen teams use this as a tool to communicate to backend teams that are also responsible for either those APIs or those endpoints.
Great, moving along. How does the front end know where the backend transaction is? Do I need to configure something specific to get this functionality, or is it enough just to use the automatic instrumentation?
So I think Jeremy kind of touched on this related to passing headers, but it's really dependent on instrumenting performance in your front end and in your back end to get that full service, cross-service visibility. That's really, I guess, generally and at a basic level, the instrumentation we went over, I guess, was solely for the front end, but there are plenty of backend docs on instrumenting. So it's all going to take place in the Sentry init statement in your front end and your backend project. And that should take care of passing those headers, propagating that contextual information related to tracing effectively, and representing that, sending it to Sentry, where you can sort of trace through as we just did in real time.
Excellent. Where do you configure the misery threshold?
So I believe that is well, I think Jeremy might be able to speak to this, but we're starting to roll out project-specific misery configurations.
Yeah, there's been some very recent changes here, so I can jump in. So we originally had there was a global user misery threshold that was configurable, but it was basically just one org-wide setting. It's now possible to configure project level defaults. So you can say for each project what the user misery threshold should be. And it is also possible, I'd have to go back and double check if this is still in beta. So it might be you have to turn on your early adopters flag to see this, but we're also rolling out transaction level thresholds as well. So you can customize at the project level and then customize again at the transaction level if there are particular transactions where they're going to take longer and that's okay, or you have more aggressive performance targets for those.
Great. Are there any integrations with OpenTelemetry?
So I might need to lean on Jeremy again for this one. Currently, I don't believe we have integrations for OpenTelemetry, and that doesn't, well, there's some history that we actually have some good docs on the origins of Sentry's tracing API and how it's definitely drew some inspiration from the precursors to the current OpenTelemetry spec. But I think I will defer to Jeremy in this case for what's on the bleeding edge when it comes to OpenTelemetry.
Yeah, happy to jump in there. So yeah, it's there are some fundamental incompatibilities. A lot of the tracing and spans, a lot of the terminology is shared, and a lot of the design of Sentry's performance solution and the way it's implemented in the SDKs was drawn from earlier versions of the OpenTelemetry spec. There were some changes as the spec kind of reached towards release, and the Sentry performance product was shipped before that happened. And the main thing is that we have this transaction concept that makes it very easy to sort of zero in and find the things that you're looking for and understand sort of to correspond to a page load or a navigation or so on. OpenTelemetry doesn't have that concept. The fundamental unit is sort of a span, and so what you get in your trace is essentially a stream of spans with some of which may represent transactions or not. So there's a difference in the model there. That's the challenge. We have experimented with like an OpenTelemetry converter where we kind of like take a Sentry event and try to convert it into OpenTelemetry. I think that's available as open source, but I would say it's experimental for sure. So like, do not rely on it, do not use it in production. But if you're interested and you want to dig in deeper to kind of see some of the differences and how that works, that's one place you could go. It's definitely something we're looking into and something that we're evaluating whether it makes sense to support in the future. We're very aware of some of the changes and kept up on the spec and so forth. So it's something we're looking at, but it's not like out of the box 100% compatible today.
Got it. We have a lot more questions, but not enough time to answer them all. So I'm going to try to squeeze in a couple more before we have to wrap things up here. Can child transactions get unreported if the child service has a low sample rate, or the parent transaction makes sure all their children get reported?
The head-based sampling will override. So basically, if the front end decides to sample the transaction, the back end will obey that sampling decision, assuming it receives all the right trace headers, which out of the box it should. The only reason I say is because sometimes there can be security setups or different things that you may have to, there may be issues that can arise that you need to work around. But once the tracing is set up properly, the sampling decision will propagate from the front to the back using kind of the head-based sampling approach, which it should be noted can increase your backend sampling rate. So the fact that you've set a backend sampling rate of say 10%, you might see more than 10% of your transactions if you're also sampling the front end and you're also tracing. So what some folks prefer to do is kind of set a lower backend sample rate to make sure they've got some and let the rest be made up by the front end sampling using that approach.
Got it. All right, last one. And if we didn't get to your question, we'll make sure to follow up with you afterwards. There's just so many more and so little time to get through all of them. I appreciate the engagement though. Let's see here. What is the, oh, I think we already answered this one. What headers do we need to whitelist in CORS configs in order to make tracing work between front end and back end traces?
So I believe it may just be the Sentry trace header, but I might be forgetting one. Jeremy, is there another header that might be needed there as well?
No, I think that's it, but I'm not 100% sure. That should be thoroughly documented though. So if you, and there should be sections specifically about what to whitelist. So I'd consult the documentation just because I'm not 100% sure off the top of my head.
Got it. All right, everyone. Thanks so much for joining us today. Again, if this is your first time, we do these every month, so be on the lookout for emails for next month's workshop. And again, there's a quick 2-question survey that'll pop up when you leave. We do these workshops for you, the developer. So anything you can provide us on how to make them better going forward is greatly appreciated. That being said, we'll do this again in August. Thank you all for joining this month's On Tracing. And until next time, take care and we'll see you again soon.
Thanks, everyone.
Thank you.